Hey scientists, welcome back. So it is a beautiful day outside, a great day to do this lesson. Last lesson that we talked about, we had the model out and we discovered that yes, in fact, when the sun is shining on a dark surface and a pale surface, that the dark surface is going to get hotter over time. And the pale surface is not going to get as hot, right? And so we thought that's a lot like woodland and like Carver Playground. Woodland has that dark surface, which is why it's getting so hot in the afternoon. And Carver has that light surface on the playground, which is why it's not getting as hot, but that's why it's so cool in the morning. So as scientists, we know that yes, it worked in our model, but we do have to test it outside to make sure that the outside and the real world situation matches the model situation. So let's go outside.
Before we go outside, I just want to make sure that our thermometers are exactly the same, and yes, they are exactly the same. We happen to have two amazing scientists today, my children, Adam and Caitlin. So, and we also happen to have this awesome part of our yard, our driveway, that has a dark surface and a pale surface. Can you put one hand on the dark surface and one hand on the pale surface?
Ooh.
And which do you predict is going to be hotter?
Definitely the darker surface. It definitely feels a lot more warmer than this one.
Does it? Do you agree, Adam?
Yes.
Okay, so now we're going to go ahead and we're going to take our thermometers and we're going to. So our scientists are going to put one thermometer, Ken's going to put it on the pale surface. And she's going to cover it up with paper just so that we're not measuring the sun on the thermometer, we're measuring the surface temperature. And Adam's going to put it on the dark surface and cover it with paper. And then they're going to have to walk away because he's making a shadow right now. Yep. And we're going to let this sit for just a minute and then we're going to uncover it and see what it says. All right, we're back. So we're going to go ahead. Why don't we do the pale surface? You want to take the paper up, Caitlin? And it looks like we are at hot right there. All right, Adam, can you pick up the paper for the dark surface? Oh, and we're at very hot, aren't we? So was your prediction correct? Yep,
Yep.
it is.
Okay, scientists, so looking at what we saw with our model and now looking at what we did outside with our thermometers and the dark and the pale surfaces, I think it's safe to say we have our next key concept of things that we have learned, which is dark surfaces get warmer than pale surfaces when light shines on them. So we saw that in both our model and outside. When the light was shining on the dark surface, it got warmer than the pale surface. So now we want to be able to explain our thinking, talking like a scientist, the way that we've been talking this whole time when we are explaining our thoughts. So let's take a look at this.
So here's our first picture. We have two pictures of beaches. The beach that is circled, do you think that that beach is going to be warmer or cooler than the beach on the left that is not circled?
Okay, so thinking about the picture we just looked at, right? The one that was circled, was that going to be warmer or was that going to be cooler than the other picture that was not circled? Hopefully you're thinking, oh, that is going to be warmer. And why is it going to be warmer? Because it is darker, right? Let's think about our explanation framework here. So the surface is warmer, and I have a card for warmer. The surface is warmer, it's hanging on by a thread there, when light shines on it because it is dark. Because we talked about how dark surfaces get warmer than pale surfaces, right? All right, let's look at the next picture.
Now we have a picture of two different rock formations, and I'm looking at them, and the one that's circled right now, do you think it's going to be warmer or cooler than the picture that's not circled right now?
So the next picture, the one that was circled, is it warmer or is it cooler than the picture that's not circled? Well, you're thinking, oh, it is cooler than the one that's not circled, right? So let's go ahead and let's explain why. The surface is cooler when light shines on it because it is pale. So both of these last two we talked about are two ways to explain why something is warmer or why something is cooler, but yet talking like a scientist. So here's a look at our data again for Carver Elementary School, and we can see that it was cold at night. It did get a little warmer, but it was still cool in the morning, and then the afternoon it warmed up to warm and hot. When we look at this compared to Woodland Elementary School, who got the same amount of sunlight, we can see that at Woodland it was cold at night, and then it was warm and cool in the morning, and in the afternoon it got hot and very hot. We know that this is the reason that this is happening is because of the color of the surface of the playground. So looking at the playground data, we can say, yes, Carver Elementary's playground is cooler than Woodland Elementary's playground because the surface is pale. We can talk about Woodland Elementary playground. We can say Woodland's playground is so much warmer than Carver's playground because Woodland's playground is dark and Carver's playground surface is pale. So again, being able to have your cause and your effect and being able to explain it and having that word because in there are all important things when you are talking like a scientist. Now, when we were doing these investigations, I was thinking about pale versus dark and other ways you might see information about it. So let's look at this book is called Cool People in Hot Places. This will give us a little bit more insight into the sunlight and dark surfaces versus pale surfaces. Does the weather ever feel too hot to you? In hot weather, the temperature is high. What do you do when the temperature is high? How do you stay cool in hot weather? Some places have hot weather often. People in these places have ways to stay cool. This is a place where the weather gets hot. What do the people do to stay cool? This is in Australia. So let's see what people do to stay cool there. People build underground homes here. Sunlight can't reach underground. The houses are cooler underground with no sunlight. Here's an underground home. Isn't that interesting? This is in Turkey. It says this is a place where the weather gets hot. What do the people do to stay cool? The people who live here build into the sides of cliffs. The cliffs make shade. Sunlight does not shine on the buildings very much. The buildings are cooler in the shade. And you can see they have caves and places to go into. This is a place in Greece. This is a place where the weather gets hot. What do the people do to stay cool? Do you notice? Look at all the buildings. What color are they? People paint their houses white and other pale colors. They paint all the surfaces, the walls and the roofs too. In the sunlight, pale surfaces don't get as warm as dark surfaces do. Pale surfaces make the houses cooler. Isn't that a smart idea if you live in a really hot place to paint your whole house white? This is in Thailand. It says this is a place where the weather gets hot. What do people do to stay cool? People build houses with big roofs to make shade. The houses also have open spaces to let fresh air come in. Air can even come under the houses. The houses are cooler with shade and lots of fresh air. Look at that, the air can go underneath there, through the windows. Keep it nice and cool. This is the place, this is in Libya. This is the place where the weather gets hot. What do the people do to stay cool? People build roofs over the sidewalks. Between the buildings, the roofs make shade. The sidewalks are cooler in the shade. Isn't that interesting? So here's a sidewalk and they built these roofs over to make it cool. This is in Oman. This is a place where the weather gets hot. What do the people do to stay cool? People wear clothing in pale colors. When sunlight shines on them, pale colors don't get as warm as dark colors do. Pale colors help keep people cool in the sunlight. So think about it, if you're going to the beach or you're going to go spend a whole day at an amusement park or at a fair, you would want to wear light color clothing, right? Like a white t-shirt instead of dark color clothing, because the light color is going to keep you cooler than the dark colors. This is in North Carolina. This is in our country. It says this is a place where the weather gets hot. What do the people do to stay cool? When it gets too hot, people set up cooling centers with sprayers. The sprayers send out tiny drops of cool water. The water helps people cool off. And there's that spray, right? I've seen those at amusement parks before, waiting in line for things. All around the world, people have different ways to stay cool in hot weather. Some wear pale clothing, some find shade, some even live underground. What do you do to stay cool? And that is the end of our story. Okay, scientists, so all of our hard work, all the things that we now know, I want you to think about what could Woodland Elementary School do to help make their students more comfortable? We even just read this book, right, about cool people in hot places and the things that they did to make themselves more comfortable in hot weather. What could the kids at Woodland do? What could we do to the playground? I want you to either send a video to your teacher, you could write it down on a piece of paper, you could draw a picture. I want you to express your ideas and thoughts, and then we're going to talk about them in our next lesson. So I can't wait to hear what you come up with, what great ideas you have to make the situation better. Can't wait to hear.